The RFID safety sensor RSS16 can be used as a door stop with integrated magnetic latching function, or can be used as a non-contact system. The electrical connection is made either by an M12 plug-in connection or with a terminal compartment with 4 M16 cable entry openings populated with either screw or cage clamps. The RSS16 can be actuated from 3 directions depending on the required installation. The electronic non-contact RFID safety sensor RSS16 interrupts any dangerous movements when safety gates on machine housings are opened. After assembly of the support plate, first slide on the stainless steel base plates with shock-absorbing pads, then flip on the guard clip and push in the pin for manipulation protection. With operation from bottom side, the RSS16 is mounted on the door frame without the attached shim. The damped magnetic latching acts in the same way as a door stop. This combination allows all-round offsets of 2 mm in a single assembly unit. After the 24-volt supply voltage has been applied, the self-monitoring safety sensor makes 2 safety-oriented OSSD outputs ready for safety evaluation and a diagnostic signal to a PLC. The safety signals can be passed through additional electronic safety devices in series for safety evaluation. With SD devices, the diagnostic signals are also fed in series via a gateway with a common field bus protocol for further processing in a controller. Extensive accessories allows for plug-in installation, simple commissioning, and extensive diagnostic functions. The multi-fault protection increases the operational safety due to the targeted fault tolerance and preventative diagnostics. If, for example, a shorted contact fault is diagnosed in the connection lines during operation, the controller receives a diagnostic signal to abort the current action orderly or to perform a shutdown. After the initial fault diagnosis, the safety outputs remain switched on for a further 30 minutes before they also shut down. This allows unregulated shutdown processes and prevents associated hazards or rejects. The wide switching region of up to 9 mm across the sensor, as well as a height offset of up to 27 mm, ensures high operational reliability. This large tolerance range applies to the non-contact RSS16 for all 3 directions of actuation. The machine function remains available even with large installation tolerances, vibrations, or door offsets during operation. The green LED signals operational readiness. Yellow indicates an actuator in the region of the system. If the actuator is located in the boundary area, this will be indicated by yellow flashing and a signal on the diagnostic output. This allows corrective adjustment before a malfunction occurs if there is a door offset. Standard coded RSS16 are operational with a factory delivery state. Individually coded sensors and actuators are very easily combined. First, the safety sensor is switched off. Then the power supply is switched on again, and the actuator is brought into the detection area. The teach-in process is signaled at the sensor with the illuminated red LED and the flashing yellow LED. After 10 seconds, the short flashing impulses requires the supply voltage to be switched off. The next time the supply voltage is switched on, the actuator needs to be acquired again to activate the taught activation code. The RSS16 variants with individual coding ensure a high level of bypass protection and is therefore suitable for protection equipment where the temptation to manipulate is quite high. If, with these sensor variants, a replacement actuator is used instead of the taught actuator, then this condition is recognized by the sensor and is not released. False actuators are recognized and are indicated by 5 red flashes. The actuator already taught remains operational. With individually coded sensors that are of the type I1, the initial assignment of the safety sensor and actuator is irreversible. Type I2 sensors can be taught multiple times, and the actuator teach-in process can be repeated indefinitely. To teach in a replacement actuator, the teach-in process is repeated with the new actuator. This causes the code to be overwritten, which means the original actuator is not recognized and is rejected. After the teach-in process of a replacement actuator, a 10-minute blocking release ensures an increased manipulation protection. The green LED flashes after completion of the relearn process until the blocking release duration has expired and the new actuator has been acquired.